Welcome back. Today we're going to be talking about indices and logarithms. Indices and logarithms. Indices and logarithms. Indices and logarithms, it's a very key area in mathematics, and with it you can solve even a lot of computer issues. But mathematics is used wide and far even in the business world. So it will be good if you can actually take this to art, take it very seriously. Today, what we're going to be discussing is the rules that guides the indices and the logarithms aspect of mathematics. And there are 7 or 8 in number. The first rule, rule number 1, shows that a raised to power m times a raised to power n is equals to a raised to power m plus n. That means if they have uh, the same roots, they have the same base, and then they can actually be the multiplication is equivalent to the addition. This is rule number 1. It's basic. Rule number 2, we have a raised to power m divided by a raised to power n is equals to a raised to power m minus n. When you have a division between them, this division, that means you should know that you have a minus. Rule number 3, when you have a raised to power m, bracket all of them and bring n raised to power n again, that shows that the a, which is the base, raised to power m multiplied by n will be the factor. Rule number 4, all these rules are going to be used in our subsequent example. Rule number 4, when you have a raised to power 0, automatically is 1. Rule number 5, when you have a raised to power minus n, that means it's the same thing as a raised to power, it's the same thing as 1 over a raised to power n. When you have rule number 6, when you have a raised to power 1 over n is the same thing as n into square root of a. Rule number 7, when you have 3 let me say, when you have a raised to power n over n is the same thing as n square root of a, then multiply everything by n. These rules are very key in indices usage. When you have any questions in your WAEC or JAM or SSC that relates or that have this form, always note all these rules. because it will help you to be able to get to the right answers. This same rule is also applicable to logarithms. But now we're going to be taking some example to solve to let you see how these rules come to play and how useful they are in our day-to-day life, and how we can use it to solve problems in mathematics. Okay, back to the indices and logarithms. Let me now take rule number 1. If you have 5 raised to power 3 multiplied by 5 raised to power 4, and we know that rule number 1 says that a raised to power m multiplied by a raised to power n is equals to a raised to power m plus n. Can you see the 3 is equivalent to m and the 4 is equivalent to n? So what we having now is going to be 5 raised to power 3 plus 4, which is equals to 5 raised to power 7. It's very easy. Can you see that? The next rule, which is a raised to power m divided by a raised to power n. Take for instance, we have 5 raised to power 3 divided by 5 raised to power 4. What this means is that, or let's say 5 raised to power 5 divided by 5 raised to power 4. What this means is that 5 raised to power 5 minus 4, which is 5 raised to power 1. This is the second rule 2. This is rule 1. Then rule 3. If you have, rule 3 is m raised to power m and n, which is the same thing as a raised to power m times n. Then we now have a raised to power, let's take for instance the a. The a is 5 raised to power 3 and raised to power 4, which is 5 3 times 4, which is 5 raised to power 12. Rule 4. This is very easy. When you have a raised to power 0 is equals to 1. Anytime you see a word or a base that is raised to power 0, just equate it to be 1. Which is when you have, take for instance, you have 5 raised to power 0 is the same thing as 1. This is mostly used in base numbers. Now in rule 5, when you have a raised to power minus n is the same thing as 1 over, because it's minus, just make it 1 over a raised to power n. Take for instance, you have example is when you have 3 minus 3, which is 1 over 3 raised to power 3, which is 1 over 9. 1 over, sorry, this is 1, 27. Now back to the example that we are doing. Now when you have something like this, 1 over n raised by, the base is a. You have something like this means that this turns this to be square root of n square root of a multiplied by 1, because 1 is out here. If you have a raised to power m over n is equals to n square root of a multiplied by m. So when we have an equation like this, 27 1 over 3 is the same thing as 3 cube root of 27 multiplied by 1, which is the same thing as 3 cube root of 27, which is the same thing as 3 times 3 times 3. So the answer is 3. If you have something like this, 4 raised to power 1 over 2, which is the same thing as 2 square root of 4 but remember there is a minus. This minus means it's over 1. That means everything we're going to be doing is 1 over 2 root 4, which is, what is root 2? What is root 4? 1 over 2 is 2. So we'll put 2 here. So this is the answer. If you have 8 2 raised to power 3, it's the same thing as 3 root 8 bracket 2, which is the same thing as, what's the root? What can we multiply together 3 times? That will give us 8, which is 2 divided by, raised to power 2, which is 4. Now the next example, it's a little bit harder, but simple, very simple. You say that's ironically. If you have something like 3x is equals to, let me erase this. If you have 3 raised to power x is equals to 81, we can actually find the roots that will give us the base of 3. What I mean by that is that if you put 3 here, x, and you say 3 raised to power 3, that means 3 times 3 times 3. That will not give us would that give us the answer? No. 9 times 9 times 9, would that give us the answer? No. But if you say raised to power 4, you say 3 times 3 times 3 times 3 times 3, which is the same thing as 3 times 3 times 3 times 3. This is 27 times 3, which is 81. So we can now say 3 raised to power x is equals to 3 raised to power 4. Cancel out the bases. We'll have x is equals to 4. If you have something like 8 raised to power x is equals to 0.25, It's the same thing like saying 2 raised to power 3x is the same thing as 25 divided by 100. And we now have here 1, here 4. That means we have 2 raised to power 3x is the same thing as 1 over 2, 2. If you find the square root of this, it's going to be 4. What can we multiply that will give us this? If we 2 raised to power 2 is the same thing as 4, and that's why we splitted it to a smaller unit that can give us the base of 2 by 2 and 2. So now what this means that we have 2 raised to power 3x into is equals to 2 raised to power minus 2. Now we are actually doing a reverse of the indices rules. Now we now have the same base. We can now cancel out the base. Cancel out the base here. And we can now have 3x is equals to minus 2. Then x is equals to minus 2 over 3. Another example I want us to look at is this particular. It's getting a little bit tougher, and I think it's quite interesting if you note it from the onset. Now, if you have something like 2 raised to power 2 raised to power 2x plus 4 raised to power 2x minus 32 is equals to 0. What we can do is make everything into the base, to the same base, using this law. A m plus a b. So we'll have something like this. 2 raised to power 2x plus 2 raised to power 2, 2 raised to power 2x minus 2 raised to power 5. Now with this, we can now remove 2 raised to power 2 out. What we're going to be having is 2 raised to power 2 x plus 2 raised to power 2 plus 2x is equals to 2 raised to power 5. Now, with this, we can still have it that is 2 raised to power 2x raised to power 2x okay. So when you have this format, what you need to do after splitting it like this, there are different ways of solving this particular problem. You don't have to adopt this. What you need to do is it's so simple. Since you have it in this format, rewrite it like 2 raised to power x into 2 plus 4 into 2 raised to the power x into 2 minus 32 is equal to 0. Then let 2 raised to the power x be x. That means you have x squared plus 4x plus 4x there's a problem with this equation. This is not supposed to be here. Okay. Since that is not there, I still need to run take off this. And we know that our x is our 2 raised to the power x is x. So this is going to be 4x minus 32 is equal to 0. Then this has turned out to be a quadratic equation. And what we need to do is to solve quadratic equation. Solve this quadratic equation. What can we add together or subtract together that will give us 4 and multiply that will give us 32? That has to be 8 minus 4. That means we have x squared plus 8x minus 4x minus 32 is equal to 0. So if we collect like times, what we're going to be having is x squared x minus 4 plus 8 plus yeah, you can say 8 x minus 4 is equal to 0. So the roots of this equation is going to be x minus 4 bracket x plus 8. That's the root. Then we know that x is equal to 4 or minus 8. Now since 2 raised to the power x is equal to x, that means 2 raised to the power x is equal to 4 for the first one. Then 2 raised to the power x is equal to 2 raised to the power 2, where x is equal to 2. To complete that, when we have x is equal to minus 8, 2 raised to the power x is equal to minus 8, 2 raised to the power x is equal to 2 is equal to minus 2 raised to the power 3. That means x does not have a solution with this root. So the solution is this. X is 2. That is the only solution this equation has. Thank you.